Hi, here we've got the typical standard example model from Revit, the Revit architecture example model. And basically what I've done here is I've just stripped away a bunch of stuff. So I've removed the roof and a bunch of non-essential model elements, because what we're going to do is we're going to take this into a platform that I'm busy working on. I'm calling it BIMWERX Crowd Control. For now, it'll probably have a better name later, but what this does is it consumes the Revit model, and we try to keep it as basic as possible, because we are analyzing the topography and all the boundaries, because what we're going to do, as the name suggests, is to simulate evacuation protocols and times and routes throughout your model. So this could be a building, it could be an airport, it could be anything really. But from here you can see we've got multiple individuals placed in various parts of the building, and there are multiple levels, and obviously there's some obstacles like the trees and things in the way. And the blue areas is the areas that the software has detected as walkable surfaces. So all the blue regions walkable, and then of course the stuff that's not blue means it can't pass through there. We've got multiple entities placed here, and we can place more. I'll just left click and it'll place another person right there. There's a bunch of other parameters that I've set up here. So we've got things like the maximum speed, acceleration. There's a whole bunch of different stuff set up here for different sort of personality types and mobility conditions, and so on and so forth. But what we want to see is if we place a target somewhere in the model. So let's say here where the parking area is, if we look at our Revit model, there's a parking area here to the side of the building. If we placed a marker here, a target, if I left click there, you're going to see that all of these units are going to start to find their own way through the model, running up and down the staircases wherever available, and then all the way down to the bottom level so that they can meet at that point. So you'll notice here we can see those ones moving down the stairs. So there's a staircase there, and if we rotate this model a bit, you'll see they're actually running down that staircase. So there we go, they're moving. Here's one standing still thinking about what to do. In this particular case, we've got a few individuals in this room because there's no exit. You'll see the pathway there, the exit wasn't narrow enough on that door, or there might have been an obstacle, or whatever the case may be. But yeah, it's pretty cool because it's real time. We can actually place additional agents in the model, or we can move the marker. You'll see if I move the marker to this position, suddenly the whole crowd will flock to that position. And if I go back here to creating more agents, we could actually place additional agents or individuals or whatever you want to call them in the model, and they will start moving or flocking towards that target point. So we can go ahead and place 1 million of them if we want. And again, if I then go and be funny and move this target again to a different location, let's say we place it over there, you'll see that all the trajectories and the paths of these agents will change, and they will start moving towards that point. You can see them running up the stairs there. It's important to note also that all of these agents knows not to clash with each other, so they avoid each other. They can't occupy the same space, which is what we want to see. And again, we'll just move that marker point, see what happens now as our horde of agents start flocking towards that point. And once they get close to it, we can see that they start grouping around as people would do. Of course, the speed here is relatively fast. They're probably running. We can set the speed here, and we can reduce that a little bit and say, now let's slow this down quite a bit, and let's move that marker point back to the bottom, and we'll see suddenly we've got movement again. Most of the behavior would be to follow the crowd until there's a bottleneck, as you see here. And once there is a bottleneck, because there's a staircase on this end, then the agents will decide to search for another faster route where there is no bottleneck. The purplish color you see there are the followers. So just like with natural human behavior, you would have some leaders and a lot of followers, so the purple ones are deciding to follow and see what the other ones do. Finally, they realize they're not getting through at that point for whatever reason, so they are heading back to this location. So this is quite interesting in terms of trying to predict and study human behavior and pedestrian moving and crowd reactions. So you can imagine all of the scenarios and use cases where this can be applied. So this is still a work in progress. The idea is to integrate this with IFC files, so you can just import IFC files straight in here. At the moment, there's a bit of a model conversion process required to get the model in here. So we want to import IFC. And then also we want to import spreadsheets, which is going to give you spawning points, points of interest, things that might distract people, like ticket gates or custom gates or whatever it might be. And then also we want to be able to place some markers within our Revit or ArchiCAD or whatever software we're working with, where those agents will be spawned from. So there's a bit more to happen here, a lot more closer integration that we would like to see with BIM modeling software. But yeah, it's definitely exciting stuff. I'll keep you updated on how this develops and where we go with this. Yeah, thanks for watching. Cheers, bye.